Thank you to the AMPS conference for allowing us to present our topic here on off-grid solar-powered EV charging stations with a focus on undergraduate creative inquiry research.
Hello, my name is Shannon Casebeer. I'm with Kansas State University in the Carl R. Ice College of Engineering and specifically in the G.E. Johnson Department of Architectural Engineering and Construction Science.
And I'm Derek Clements, also in the Architectural Engineering and Construction Science Department. We're a little bit unique in that we have both of those combined into a single department, so we have students and faculty on both sides. I typically teach mostly on the architectural engineering side, and Shannon teaches mostly on the construction science side.
As the title of our presentation indicated, this is an undergraduate research creative inquiry project, and the primary focus of it was development of an off-grid solar-powered electric vehicle charging station. And through this development process, we wanted to come up with a design that was simple, that had a modular aspect to it, that was adaptable to multiple parking lot configurations, and was affordable. And based on the long name of our department, which you might have noticed, we have really two sides there. There's the architectural engineering side, where our students are educated to become systems designer related to buildings. And on the other half of our department, our students are educated to become construction managers. And since those two groups, the construction design side, collaborate in industry, we're grouped together within the College of Engineering. And so this research project provided an opportunity to get those two groups of students together to work on a design build project collaboratively. And our project, in a small way, supported the university's sustainability initiative. So this next slide shows a list of students who have at various times worked on this project, and you can see that the mix of students here shows both sides of our department. And I would say 80% of the students listed here worked during the design phases of the project and have since graduated and gone on to begin their careers as architectural engineers or construction professionals.
So if we back up just a little bit, thinking about the purpose behind coming up with this off-grid electric vehicle station, we know that the number of electric vehicles in the United States is anticipated to grow tremendously. There's a significant infrastructure issue that we need to deal with to make sure that those vehicles have a place to charge. Much of the infrastructure focus has been thus far on fast charging speeds, making sure that we can provide as much range as possible in as short of a time span as possible. We are kind of looking at this from a different approach, recognizing that for many of us, we may drive to work. We're going to park our vehicles. That vehicle may be parked for 6 to 8 hours. That'd be a perfect opportunity to provide some what's called opportunity charging, enough to be able to at least get us to and from work. Studies have shown that approximately 95% of trips take place in less than 30 miles. So if we can provide at least 30 miles of range per day, that's going to suffice for the majority of our population. Now, an easy way for us to provide that charging is just to install a standard electric vehicle charging station where we can park again on campus and charge all day. The problem with that is potentially that could align with peak demand periods. Think about charging a whole bunch of electric vehicles at 3 p.m. on the hottest day of summer. That's going to provide additional demand on the electric grid that could potentially cause problems. So instead, if we can provide an off-grid solution that may end up being a slower charging solution, we can be able to meet the needs of those EVs. So we looked at what options currently exist. Is there anything out there that is readily available off the shelf? And surprisingly, the options are fairly limited. So we were able to find a somewhat similar system that's shown here that, as far as we can tell, that cost is roughly between $60,000 and $85,000, depending on options. This system includes a 4.4 kW array, includes batteries, and has the ability to charge 2 vehicles. So our goal was to provide something somewhat similar, but at a lower cost.
So as Derek mentioned, periodic charging or interval charging or day use charging was one of the primary design considerations of the station as far as how it would function. And regarding performance of the station, we had design discussions to try to understand how many panels and how many square feet of surface area would be needed on the array to generate enough power to power 2 electric vehicles. Again, looking at what systems were available on the market, our goal was to come up with and develop a system that was more cost-effective way of achieving that same result. And so other design considerations that we looked at were adaptability of our system for different parking lot configurations, modularity of our system. We ended up looking at different sites and ultimately settled on the third site that our team analyzed. We considered weather and climate here in Manhattan, Kansas, as that related to the design of the system. We also looked at public safety, vandalism, long-term maintenance of the system. We had a lot of conversations about constructability of the system, again, seeking to come up with a design that was efficient to construct and also safe for workers and students to participate in that installation. We analyzed the foundation requirements of the system and initially settled on a drilled pier type of foundation. We also looked at the primary and secondary structures of the station and the array. We looked at the electrical system with regard to power generation and storage. I mentioned cost a moment ago. That was a significant topic that we looked at. Even though this is designed to be an off-grid station, we also wanted to make sure that we examined the possibility of grid connectivity if we determined later that that was something that we were interested in doing. Initially, this station is going to be offered for use on campus free, but we wanted to understand the revenue potential and make sure that the station had the capability built in so that users could be charged for using the station. And finally, we wanted to understand what type of data we would be generating over the lifespan of the station and how we would collect and disseminate that information and who might benefit from analyzing that data. These next couple of slides show the adaptability of our station as far as how it might be used in different parking lot configurations. So the diagrams on screen were put together by our students, but this first slide shows a couple of different configurations, again, thinking about the fact that this station is designed to serve 2 EVs. These 2 diagrams show how that station could be located in a grass island or grass median in a parking lot between rows of parking spaces. The next slide shows in configuration C how the station could be located on the outer perimeter of a parking lot. Configuration D shows how the station could be located at the end of a couple of rows. And this last slide shows a couple of different configurations where we explored the question of could this station be placed out in the middle of a large parking lot. And so all of these configurations were examined, and our basic conclusion was that yes, that our station would work in any of these configurations. Some of them had pros and cons, and some of them were more or less desirable than others.
So as we worked through the design, we had a couple of different iterations. Our first iteration, shown here on the screen, shows essentially a cantilevered option, where we have a drilled pier that would be drilled down, poured concrete, pole mounted on that, and then the frame would actually cantilever over the parking structure to provide a little bit of shade to those that are parking underneath. What we're seeing here, we can see structural calculations from some of our students on the left-hand side. The plans that are shown here, these are all plans that were put together by those same structural students. They also came up with, beyond just the calculations, the actual modeling. So they initially started with the Revit modeling that you can see here on the left-hand side. Again, thinking about adaptability of how we can take this and apply it in multiple different scenarios depending on the parking layout. So we ideally would like those panels to face south, but that doesn't always correlate with the actual parking stripe. So we wanted to make sure that we could adapt this. Those panels could be oriented in a manner that would allow it to get the most sun regardless of how the parking is laid out. Once we had that initial design, we wanted to mock that up, test it out, make sure that it was actually going to supply enough power to be able to charge a vehicle. We wanted to make sure that we understood how the pieces and parts were going to go so that we could eventually construct this on site. You can see there the construction as we're constructing outside. We're wearing masks. This did happen to take place during COVID, but we persevered through there. We were able to get this constructed. We did not have a location on campus, and so once a week we would take a field trip over to my house and build this out in my driveway, store it in my garage, and wheel it out so that we could continue building and then ultimately test it. Beyond just the structural and electrical portion, we also had the construction portion that we were tracking throughout the entire design process. So here's an example of an estimate that was put together in order to help us make sure we were staying under budget as we're trying to build just the mock-up. We went through and analyzed what the different costs would be in the different divisions and ultimately came up with a cost of about $4,700, which ended up being fairly close to what we spent on this mock-up.
So as we mentioned earlier, with the 2 distinct halves of our department, we're all about collaboration, and we want our students to understand what that really looks like. And so as we worked on the development of this project, we discussed with the students, providing pre-construction services in design, build, project delivery, and attempted to kind of emulate that with what we were doing in our research project. And that involved performing iterative cost estimating. So as the design developed, we had students working on performing material takeoffs. The students looked into the procurement of the materials and equipment necessary for construction of the station, including investigating lead times that were impacted by the COVID pandemic. The students did labor analysis on the station to try to understand what would be involved when it came time to actually construct the station, as well as what the crew mix of different trades or professions might be that would be involved in those processes. The students looked at the equipment needs for the project and ultimately selected pieces of equipment for the different stages of the construction installation. And finally, they looked at what subcontractors might need to be involved at certain points during the construction portion of the project. And so numerous discussions were held among these groups about constructability, again, looking at how can we build this thing efficiently, how can we utilize readily available materials, how can we design it to be assembled in a safe manner, and also have the station perform in a manner that's safe for the users and the general public. And this process of going through these iterations as a group allowed us to inform the design in real time. As we were able to provide this cost feedback, the students would take the information away from our weekly meetings and go price out any changes to our design and bring that information back, and that allowed us to make informed decisions as a group going forward.
So as Shannon mentioned, those informed decisions, what we ended up finding out after we constructed our mock-up was that this ended up being a little bit more labor-intensive and material-intensive than we would have liked. However, we were able to take that mock-up and still use it to gather some information. So we looked at orientation of these panels. We also looked at what happens when these panels are dirty versus clean, how much power do they generate. And again, we're able to prove out that this system would, in fact, work the way that we anticipated.
So finally, we reached the end of our initial design phase. And when we got to the finish line on that, we kind of took a step back and realized that the solution that we'd come up with wasn't really achieving what we'd initially set out to accomplish. And so that ended up ultimately sending us back to the drawing board. But the problems that we identified, first of all, were constructability concerns with the drilled pier foundation. As we got deeper into analyzing the loads, wind loads and uplift loads on our charging station, we realized that the drilled pier would need to be installed to a depth that exceeded the capacity of readily available rental equipment. So that was a major problem. The second thing that we came to understand, we had a student who was a participant in this project who worked for a local steel fabrication shop. And so he was able to help use that connection to check the cost of our proprietary cantilevered primary and secondary structural system, and it ultimately proved to be more expensive than what we had initially anticipated. And then the final challenge that we recognized was that we wanted the panels to be pitch adjustable. Our pitch was adjustable, but it was a very labor-intensive process. So for all these reasons, we decided to sideline our initial design, go back to the drawing board, take the lessons learned from this initial design, and see what we could do to make it better in the next iteration.
So we gave this task to the students, asked them to look at how can we reduce the materials while also keeping in mind making sure this is pitch adjustable and safe to construct. They actually came up with a great solution and worked with a manufacturer that we'll talk about here in just a minute. But they took that initial design, very much simplified it to what you might think of as more of a standard canopy that you may have seen, and modeled it up. And ultimately, what you can see down below is the finalized version, the construction of that panel. So during that design process, we moved away from that drilled pier and instead went with a 7-foot by 7-foot slab with a pole that's secured via base plate and bolts. We decided to mount most of the electrical equipment on top of that foundation pad, bringing it up a little bit and providing some protection for the electrical equipment. Again, what you're seeing here, these are drawings that were put together 100% by our students with just input from faculty and a couple of engineers to get them to this point, but essentially getting us to the construction drawings phase so that this could actually be constructed based on what the students put together. So with our final design, we ended up with an array that looks similar to this. We are currently waiting on some of the electrical infrastructure to be delivered and installed. But ultimately, we've got a 10-panel array with a battery bank down below that then goes off to our charging station. We anticipate that this should provide roughly 16,500 miles of EV range per year, which works out to about 30 to 54 miles per day. Of course, this isn't going to bring you from 0 to 100% on your EV charging, but as we saw earlier, that should suffice for the majority of trips that are made. So recognizing that this is just going to be a partial or a top-off charge is going to be critical, and it's one of the things that we want to make sure that is conveyed to all those that use it. We want to get some feedback from that as well.
So as Derek mentioned, we ended up rethinking the foundation design, and we also had to take a step back and reimagine what the upper framework of this charging station might look like. And that led us to abandon our proprietary cantilevered, custom fabricated steel design in favor of an off-the-shelf solution. So we began looking into what was out there, what was readily available. We found several companies that offered frame kits, and we stumbled onto a company called Montana Solar, and this is ultimately who we selected, but we selected the MT Solar for a couple of different reasons. And the first of which was that it offers user-friendly pitch adjustability. You can kind of see in the photograph there on the left, a gentleman standing on the ground, and in his hand is a giant crank handle, and so you can literally stand on the ground, crank the handle, and change the pitch of the entire array without having to climb up on a ladder. So we really liked that feature of it. The second thing that we liked about it is the MT Solar kit system has what's called a climbing collar, and you can see in the video here that piece that just attached to the primary column. There's a hoisting insert that goes in the top, and you can basically construct the entire secondary frame of the array while standing on the ground. And once that assembly is complete, you use a chain hoist and raise the entire array up to the top of the pole, where you then remove the lifting insert and drop in the last panel. So from a simplicity, constructability perspective, this ended up being a winning solution. And from a cost perspective, this also saved a significant amount of money over our original proprietary solution. And so we sort of formed a partnership with MT Solar where our students could collaborate with them and perform the analysis necessary to make sure that the upper frame would be designed for our 10-panel array and would serve us well here in northeastern Kansas. So as part of this process, we continually evaluated the cost of this system, and when we reached the end of this redesign utilizing the monolithic foundation and the MT Solar upper frame system, we ended up with a solution that landed in the range of $35,000 to $40,000. And based on our initial market research and what we saw competing off-grid systems going forward, we felt like that we were definitely moving in the right direction. So as we started to get our ducks in a row as far as moving into a phase of building a prototype of this station based on our redesign, we also sought in-kind donations. And so the student that I mentioned earlier that had worked on the project for that local steel fabricator ended up going to work for that company after he graduated, and he was able to convince them to fabricate and deliver the primary column free of charge. So we got an in-kind donation from that steel fabricator, and one of our architectural engineering alumni who specializes in solar system design agreed to review our electrical system design and donate his professional hours, and those two things resulted in an in-kind donation savings of $5,000. Also during this process, Derek and I applied for an NCEES Education Award, and we were fortunate enough to be granted that, so that provided a $10,000 award that we were able to apply towards the construction of the prototype station. And finally, since we're under the College of Engineering, they agreed to cover the remaining costs to see the station constructed.
Now, since the College of Engineering helped significantly with that cost, they, of course, wanted this to be right out in front of their building so that they could show it off to any students that are passing by, any new prospective students. So we, as part of that process, had to work with the College of Engineering, Parking Services, and Facilities to figure out where exactly this was going to be located, making sure that we found a good location that was visible, but also safe. As much as possible, we tried to include the students in that process, sitting in those meetings to help prepare them for the meetings that they're going to be sitting in as they graduate from here.
Once we finally received all the approvals we needed from the various entities on campus that would be involved in this project, we were able to move into the procurement and construction phase. And so at the outset of this, we were assigned a project manager from the University Division of Facilities, and that project manager helped us to secure an external review by a structural engineering firm. Another thing that the Division of Facilities deemed would be helpful would be to secure the services of a local prime contractor. And that really helped streamline the procurement process and the purchasing of all the materials, equipment necessary to construct the station. And the second benefit of securing that local prime contractor was also to have someone in place to help manage the installation from an expertise and a safety perspective. So it was a large liability and risk mitigation step that we felt would be beneficial to the project. And of course, continued student involvement is another important thing. So even here during the procurement and construction phases, we've continued to have students involved to the extent possible in those processes. And as of the recording of this presentation, the station's concrete cast-in-place foundation, the station's primary and secondary structural systems have all been installed, as well as the solar panels or PV array. So we're currently gathering power from the sun, but we're not putting it to any use yet. And we're waiting on the last few pieces of equipment to come in, and finally the final phase of construction here, the power management and storage systems will be installed in late May of 2024, bringing the project to a conclusion in June of 2024.
So even though construction is nearly complete, that's not the end of the project for us. We want to take what we've learned on this first project, gather information about the usage patterns, how much are we generating, and apply that to future projects. So we've already had some conversations about potentially building more of these on campus, and ultimately it'd be great if we could expand that beyond just our campus. We're appreciative of the opportunity to be able to present here at the AMPS conference. We would love to hear any feedback, or if you have any questions, feel free to reach out to us.
Thank you.